Today's tutorial is going to be about how we multiply and divide numbers written in scientific notation. Let's start off with multiplication. So here we have two numbers written in scientific notation that we are multiplying together. So scientific notation in and of itself is a multiplication problem. So it's almost like we have two multiplication problems that we're multiplying together. So all four of these numbers are being multiplied. And when we're multiplying numbers, we can switch up the order. It doesn't matter when we're multiplying what order we write the numbers. So I could rewrite the problem like this. So when I rewrite the problem like this, what I'm doing is I'm multiplying the numbers together that come at the beginning of the scientific notation, and then I'm multiplying the exponents with the base of 10 together. So we can take it separately like this and solve our answer that way. So the first thing I'm going to do is 3.5 times 7. When I do this, I get 24.5. The next thing that I am going to do is multiply these exponents together. When we're multiplying exponents, remember if they have the same base, all we need to do when we multiply them is add the exponents. So if I have 10 to the power of -3 times 10 to the power of 5, to get my final exponent answer, I'm just going to add these exponents. So I do -3 plus 5 is +2. So the exponent part here equals 10 to the power of +2. We're almost done here. The last step is to make sure that we have this number written in scientific notation. So remember, scientific notation, it's a number between 1 and 10 times 10 to the power of something. So I'm going to make sure that this number here, it's really between 1 and 10. Well, the number I have here is 24.5. That's not between 1 and 10. So I'm going to have to change it to get it between 1 and 10. To change it, I'm going to need to move this decimal point to the left one place to make it 2.45. Well, when I do this, in my final answer, when I'm moving the exponent to the right, when I'm multiplying it, I'm going to have to move it one more place originally. Originally, with the exponent of 2, I would only need to move this 2 places like this. Since it's an exponent of 2, I would move it 2 places to get 2,450. But since I needed to move the decimal point to the left to get it between 1 and 10, now I have to move it one more additional place to get this number here. So if I have to move it one more time, that means I need to add a 1 to my exponent, because now I need to move it 1, 2, 3 places to get the same number. So just to summarize one more time what I did in this last step here, when I need to move the decimal point to the left to get a number between 1 and 10, I need to add 1 to my exponent, because now I will need to move the decimal point one more time than before to get the answer that I'm looking for at the end, written in standard notation. Now let's take a look at a division example. Here we are dividing two numbers written in scientific notation. So we're going to solve this in a similar way that we did the multiplication, where we are going to look at the numbers first here. We're going to look at them separately and the exponents separately as well. So it's almost like we're splitting this division problem in half, dividing these two numbers times the division of these two numbers. So when I separate them, it will look like this. So the first thing I'm going to do is 3 66,000ths divided by 7 3/10. And when I do that division, I get 42 hundredths. And then I will do the division of the exponents. So remember, when we have exponents that have the same base and we're dividing them, we can just subtract the exponents. So I'm doing 10 to the power of 8 divided by 10 to the power of 3. So my final answer will be 10 to the power of 8 minus 3, and 8 minus 3 is 5. So it will be 10 to the power of 5. All right, so then the next step is similar to the slide before. We need to make sure that this answer here is actually written in scientific notation. So in order for it to be in scientific notation, this first number here needs to be between 1 and 10. Well, right now this is less than 1, so it's not in scientific notation. I'm going to need to move this decimal point one place over to get it to be in scientific notation. So moving the decimal point one place to the right would make it look like this. Now we need to figure out how we would change our exponent. So up here, when I'm doing 0.42 times 10 to the power of 5, that means I'm taking this number and I would need to move my decimal point 5 places to the right, like this. And in standard form, it would be 42,000. So when I already moved the decimal point one place to the right, I already did one of these jumps. So now to get the decimal point over to here, I only need to do 4 more jumps. So I'm only multiplying times 10 4 more times. So to recap this here, when I move the decimal point to the right one place to get a number between 1 and 10, I subtracted 1 from my exponent to get the same number in standard notation. So when we move the decimal point, like on the last slide, we needed to move the decimal point to the left. We added 1 to the exponent, but when we move the decimal point to the right, we subtract 1 from the exponent. And if you're not really sure on which way, if you should add or subtract to the exponent, I would recommend making sure that when you expand this out into standard notation, it equals the same number at the end. So here is the answer in scientific form and in standard notation. Here is one more example of a division problem. Try it out on your own first, see if you can get it, and then play the video again to check your work to compare how you did. So pause the video, try it, and play it when you have an answer. Okay, so hopefully you have an answer that you've tried at this point. I'm going to explain my work of how I do this. So the first thing I did is I separated the division of the numbers and the division of the exponents. So now I'll go through and see what each one of these are. So 1.305 divided by 1.45 equals 9/10 times 10 to the power of 3 divided by 10 to the power of -4. We have the same base, so when we divide the exponents, we just need to subtract the exponents. So 3 minus -4 equals +7. 3 minus -4, I can change this to 3 plus 4, and that gets us 7. So that's how I get to this step. Then I need to change this to be actually in scientific notation. This number here needs to be between 1 and 10. Right now it's less than 1, so I need to move the decimal point to make it be at least 1 and smaller than 10. So I'm going to need to move the decimal point one place to the right to create 9 wholes. So it's like 9.0 or just 9 times 10 to the power of, then I will decide what my new exponent is going to be. So when I move it to the right, I've already moved it one of these 7 times. In total here, I need to move the decimal point 7 places. And I'm going to be moving it 7 places to the right. Well, I've already moved it 1 place to the right, so that means I only need to move it 6 more times to the right to have a total of 7 jumps to the right. So it will be 10 to the power of 6. And then to write this in standard form, I will move it 1, 2, 3, 4, 5, 6, fill in with zeros. So in standard form, this would be 9 million.